Moving on, I now request our HOD, Dr. Sudhir M, to please address the audience.
Namaste, pleasant morning to all of you. We are all experiencing the lockdown, especially those who are in the academia, faculty, students, as well as the staffs in colleges. I've always been telling that there is no lockdown on learning. Service and excellence is the motto of our institution, and this FDP, organized by the Department of Mechanical Engineering, on topic PLC Programming and Industrial Interface in association with the Indwell Automation is a step towards excellence, we feel. As all of you know, automation technology is the need of the hour. And our association with the Indwell Automation, not only for this FDP, we are interacting with the Indwell Automation, and they are our training partners from several years, imparting education and the training to our faculty and the students in the field of industrial automation. I'm very happy to note that there are several faculty from different parts of India, from different disciplines, not only engineering. We see this time the faculty from the basic sciences to know about PLC programming and the industrial interface. Very happy to see a large number of participants have registered, and you will have not only the one sessions but hands-on sessions. We request active participation of all the participants. There will be a poll questions in between, quizzes, and homework at the end of each day to have a most memorable experience during this FDP. We also request you, all the participants, to give their feedback when it is asked for, because your feedback will help us a lot in taking our mission of service as excellence a step ahead. I'm not going to elaborate on what are all the things you are going to cover, but to share you personally my experience with Mr. Himanshu Kumar in Indwell Automation few years back, when they have conducted session here for our faculty as well as the students. Today, I rate it as the one of the best FDP I have attended, because the experience was hands-on, and all the examples that we come across in the real industrial scenario are brought to the notice board, brought to the blackboard, and explained to us. So you will have a great learning experience throughout this workshop. I request the active participation of all the participants. I wish you all the best. Happy time during this FDP. Thank you very much.
Thank you, Dr. Sudhir. Without any further delay, we hand over the session to Mr. Himanshu. Over to you, sir.
Good morning, everyone. Am I audible?
Yes, sir. You are audible. Please go on. Yeah.
Good morning, everyone. I hope that you won't get bored during the session. I shall try to make the sessions interesting, but it is more required from your side also to interact in between also. If you have any doubt, you may ask me anytime. I shall stop and will clarify the doubts. Very first, be relaxed. We have 3 days and we have to go through many topics. Although these 9 hours will not be enough to learn all the things, but if we go through some method, or you can say some easiest way, I think we can learn many things in short duration. So we have to follow some sequences. I shall start from scratch. I hope some people know about PLC programming and all. But I shall start from scratch because I think many people will be not having basic knowledge of automation even. I think so. So we shall start from the scratch. I shall show you some documents also here, some PPT, or I shall show you some PDF file. I request you all not to read the things because I'm going to read, or you can say I'm going to explain that. If you will read the things, your concentration will not be up to that. So when I show you the things, you just listen to me, and when I shall tell you to read, you read that. We shall start from beginning. We shall start from scratch. First, let us have discussion about controllers, because we are going to learn automation control, PLC controller here. So we shall start from beginning. When we have to work on any automatic system, or you can say on any machine in college or in industry, we have to work actually on three parts of the machine. Often what happens, if you have faced some situation where machine is shut down, in college also, we have many machines in our lab. You might have faced some situation where the machine got some problem and you have to troubleshoot it. When you have to troubleshoot the system, we faced first problem, we see the largeness of the machine. It's very large in size, it is spread in large area. Actually, we have not to be worried about the largeness of the machine. We have to concentrate on three parts only. And you can see now on screen, it's input, controller, and output. So you have not to be worried about the mechanical structure of the machine, because once machine is ready, trials have been taken, often we don't get problem in mechanical structure, but it is sure that your machine will get shut down. There is no machine which will not stop. It will stop sometime. So when it gets stopped, you have to concentrate on three parts: input of the machine, controller of the machine, and output of the machine. Now you will say, using these three parts, how we can troubleshoot it. Often we get problem in machine because of field devices. We don't get problem in controller most of the time. Rarely we get some problem in controller, but all the time machine will get shut down because of input and output, field devices we call it. When we talk about input, in input we can have push buttons. You have seen in your lab also, you will have green color and red color push buttons. You will have a system will be used. In sensor also you have different type. We shall have discussion about that later. So when you have input, you have to find out the problem, which is you can have proximity sensor, photo sensor, other limit switches. So you will get problem with that. If you go to find out the problem in output side, you can have there most of time motor. You will have relay. You will have contactor. You can have some solenoid valves. If you have automatic system, you will have valves there, solenoid valves. So we get problem in input or output. Now you see, again we have one problem. We shall find out the issues in input and output, but the thing is, if you go for a good automatic machine, it will have, you can say 300, 400 inputs, you can have 50 to 100 outputs. So you see, practically if you go to check each and every input or each and every output, again it will take time, and it is not the proper way we follow in industry to find out the problem, because machine should not get shut down for long duration. In 5 to 10 minutes, you have to rectify it. You have to find the problem. You have to solve it, and you have to restart the machine. So again, you have seen that input controller output, we have seen input output, but still we have problem. The number of inputs outputs we have large. Now I come to the main point. If your controller is advanced, it has good features in it. In 5 to 10 minutes, you can troubleshoot the system. I shall come to the point how we troubleshoot, but before that, let us have discussion about controller from beginning, from scratch. And keep patience, please. We shall come to programming slowly, and some important part, theoretical part, we have to cover before programming of PLC. So keep patience. When we talk about controller, what is the role of controller? In simple, if we say about controller, controller takes input, whatever input you operate, it takes signal from input, it generates output according to the logic developed. Now, if we talk about the initial controller when industry started, what was the controller when industry started? It was all manual operation, right? It was all manual system. A man was the controller, you can say. Because a man was taking decision, you can say the logic. Man was taking decision how the machine has to run. A man was monitoring the system also. Like if I give you an example, suppose we have to fill a tank to some mark. You will have some mark on that tank level. So if you have to fill the tank to some mark, you will open the tap. So here one man will go, one operator will go and manually will open the tap. Now he has to monitor also. So controller monitors also what is the present status. So he will monitor, okay, level is increasing, and when he will see the level has been reached, will close the tap. So here you see a man is taking decision. A man is monitoring the system also. So man was the controller initially. But obviously it was a time-taking system. It was not accurate also. Now if you see, if you have to fill a tank up to some mark or up to some, you can say some liters you have to fill. Are you sure you would be able to fill the tank up to the exact mark or up to the exact quantity, you can say? I don't think so. It is not possible to go to the exact quantity manually. And when you go for pharmaceutical industry or you go for some chemical industries, there the quantity matters. You can't have any error in quantity. So manual operation was not accurate, and it was a time-taking system also. Very first automatic controller came in industry was relay logic controller. This is important. You should understand it. Relay logic controller was the first automatic controller. What we had in relay logic controller? A relay logic controller was actually a complicated, very complicated. Let me show you here also. Here you see, it was very complicated electronic circuit, you can say. The logic was developed, the logic was designed using wires, electrical devices, electronic devices. Many relay, many contactor, many hardware timer, hardware counters. There were many things in that, and it was so large. It was very large. Nowadays also we have relay logic control. When you go to some old industries, you go to some PSU, you go to railway, they have many systems, old systems where they have relay logic control. Now they are replacing it. So this relay logic controller was so complicated and very large in size. Now you see, I told you machine will stop. So in relay logic controller also, it was automatic, but machine used to be stopped many times. The problem is, once the machine is shut down, it was very difficult to find out problem. You can imagine There's the circuit which is very large, and initially it was that large you could go inside the circuit. It was that large. So you can imagine when the circuit is so large where you can go inside and it got some problem. We don't know where is the problem, and we did not have any monitoring system there that time. So we had to find out the problem in that complicated circuit where we had a lot of devices, small and big. We had a lot of wires. So very first issue we had troubleshooting. Another thing you see, if you have developed one relay logic control for one application and you want some modification, you want to add two more sensors, you want to remove something, it was very difficult and sometimes it was not possible. Because once you have to change your logic in relay logic control, you have to change the circuit, and it was so complicated. So two things we understand here, the limitation. First was we had troubleshooting problem. Second was it was not possible to modify the system as per our requirement. Okay, fine. As most of you are from academic side, let me give you one example where you use relay logic control in your college. Every department will have one motor, correct? In your lab, you will have motor, or in mechanical, you will have a pneumatic hydraulic system. You have seen you will have a push button. In fact, you will have two push buttons for one motor on and off. Green color push button is for on and red color push button is for off. Do you know push button has a spring system? So when we press the push button, we get signal through that push button to the motor, correct? But we are not going to press the push button for long. If you have to run the motor, you just press the push button, motor is on, you leave the push button, no problem, motor will keep running. Here you see, when you leave the push button, once you press the push button, motor will get the signal. When you leave the push button is off. It means from that push button, signal is not going to the motor, but still motor runs. Here we have relay logic control. Means we have hold that output, we have made latch of that output using one relay, we have some wire connection. So you can see here one small example I have given you, that when you have to make your logic using electronic devices, using wire, it would be relay logic control. Simple, in simple. Okay, that's it. Next, controller is very famous in academics. It is microcontroller. It is in syllabus also in academics. Microcontroller is very good controller. It is very compact in size. It's very cheap in cost. You can purchase one microcontroller in few hundred. So it is very cheap in cost. It is very compact in size. We can program it. Once we are able to program one controller, we can have modification as per our requirement. So microcontroller is very good. But I come to the reality now. I have not come here to promote PLC very first thing. So don't you think that if I say something good about PLC, it means I'm supporting PLC and I'm criticizing other controllers? No. The reality of industry is you go to any type of industry, you go to any industry like cement industry, you go to power plant, you go to pharmaceutical, or you go to oil and gas, or any industry. Nowhere machines are being controlled by microcontroller. This is the reality actually. So in industry, you are not going to find microcontroller to control the machines. We have PLC. But why don't we have microcontroller? It's very cheap in cost. It has programming option. It is very good. Let's have discussion about this. In internet, if you will search, you will have a lot conversations about microcontroller versus PLC. Let me show you the things here. I have written here, You can see I have written here microcontroller and PLC. Very first thing I have written, it's programming language. Obviously, microcontroller programming language is based on C programming. It is okay, we shall learn that, but somewhere it is a bit difficult to learn by everyone. And what we learn in college, believe me, it's not enough to make a program for one good machine. Let me tell you, in most of colleges, most of time the project is being done on microcontroller. What we do exactly? If we have to make one project, we go to internet, find out some ready-made logic, and we make small modification, and we dump that to controller, and we make our project. So what we learn about microcontroller programming is not enough to make a program for microcontroller. Okay, let it be, we shall learn and we will make program also. If we talk about PLC, PLC has 6 programming languages. As per your comfort, you can select the language, and ladder diagram is very easy to learn. Anyone can learn this language that I shall discuss further. Now I come to the second point, and this is important actually. These questions are asked in interview also. Download and upload time. Actually, when you use microcontroller, upload you use, the term you use upload. Upload means you send program to microcontroller, but it is different in PLC. In PLC, upload means you receive, download means you send. Okay, let it be. When you send program to microcontroller, it takes some time. As I had used Arduino, it is also kind of microcontroller. You can say advanced version of microcontroller. It takes some time. When you download your program to PLC in fraction of second, it will be downloaded. But still I say, these are not the important difference, or you can say limitation. We don't have this important one, but still we should know about this. I shall come to the important point further. Program receive option. Now it is the important part. I think all of you have gone through microcontroller programming. If you have not gone, no problem. You use microcontroller and Arduino. If I say, in microcontroller, we do not have receive option, program receive option. I hope you understand it. You can write the program to microcontroller, but are you able to receive the existing program of microcontroller? Have you tried? I have tried in Arduino. There is no option to receive existing program. Now you see why it is very important to receive program of your controller. Let me give you one example why it is important. You just imagine. You imagine you have a good automatic machine where you have one PLC. Again, I shall come to microcontroller, but now you imagine you have a PLC. So we have one machine. It has one PLC as controller. All input wires, output wires of the machine has come to the PLC, connected. PLC is in control panel. Now machine got some problem. What we do to find out the issues, you see. I shall take my laptop. We'll go to the control panel. We'll open it. We have PLC there. We'll connect PLC communication cable, one end to laptop and another end to PLC. As we connect these two, in laptop, we should have that PLC software, and in PLC software, you will have option receive existing program. Name will be different, like upload, receive, or other name also. So we just click that option, upload or receive. In fraction of second, that existing program of PLC will come in your laptop in that software. Now you will come to know what is the logic inside that PLC, because it's not like you have made the program for that controller and you know everything about that. Many times you have to work on the controller, you don't know about the logic, what's logic inside that. And if you don't know about the logic, how it has been working, it is being operated, how will you troubleshoot it? So you can receive the existing program, and in program, again, you have one option, very good option, monitor mode or online mode. So as you click that monitor mode or online mode, you will be online with the present status of inputs, outputs of your machine. So in your software, you will be able to monitor what is the status of all inputs, what is the status of all outputs, and now you see how it will help you to troubleshoot it. Suppose in that machine, we have one conveyor, which is running by one motor. We shall ask the electrician what is the address of that motor. It will be written on the motor. One tag will be there. Suppose that address is Q0. So in that software, you can search where is Q0. Easily you will reach to that Q0 coil in your software, and there you can find out why the main supply is not reaching to this motor. And in between you will find, okay, because of this sensor, because of this issue, the motor is not getting main supply. And directly you can reach to the particular problem. So you have not to waste your time to find out the things manually. You just go, receive the existing program of PLC, go to monitor mode, search which output is not working, and easily you can find out because of which input it is not working. And you can troubleshoot it. In 5-10 minutes, you can restart the machine. Now you see in microcontroller, we do not have this receive option. And if we don't have receive option, how shall we come to know what is the logic inside and how will we work on that? In Arduino, we have monitor mode, but that monitor mode is not enough to troubleshoot the system. Okay, let it be. So here we understand first problem in microcontroller, the limitation we find is its receiving program. We can't receive it. Monitor mode also, I have told you, I have written here monitor mode, and what I have told, I have explained here. Now you see one more good feature. Actually, it will kill our time, but there are many things here. And we have to start programming part also very fast. So let me finish it first. Another is online edit. Let it be. I shall tell you about this last day. Practically, I will show you online edit. Handling, obviously, PLC is very robust. PLC is very bulk in size, and PLC can work in any environmental condition. And let me tell you, when PLC was manufactured, very first PLC was manufactured, it got retired. It was not retired because it got some problem. It was retired because that particular department, or you can say section of the industry was closed. So they retired that PLC, and that PLC is still with manufacturer. It got retired in 20 years, after 20 years, and it was not shut down in between because of its a hardware problem or any other things. Once you install one PLC in proper way, long life it can work, and this is the reality. And I shall give you one reason also why PLC can work long life. PLC CPU will never get out of order. There is one reason. Obviously, PLC will have input terminals, will have output terminals, and CPU inside. There is no any wire connection between input of your PLC and CPU. There is no any wire connection between CPU and output terminal of your PLC. So you can see CPU is not connected directly to input output through some wires, but we have optocouplers there. So when any input is on, light is emitted to the CPU point and CPU gets signal. When CPU generates any output signal, it again emits light and output terminal gets signal. So there is no any wire connection between input CPU, between CPU and output. So once you install your PLC in proper way, you will never get it out of order. Okay, let it be. PLC block diagram. Okay, we shall have discussion about this. We won't go in detail, more detail, but still we shall see what we have inside PLC. This is PLC block diagram. Let it be any type of PLC or any brand of PLC. PLC will have all these essential parts inside it. Very first, it will have power supply. Obviously, we need to power on PLC first to work on it. This power supply you can have of 230 volt AC or you can have 24 volt DC. Remember one thing. When we talk about industrial automation, DC voltage we use there is 24. So 24 volt DC will be used if you have to power on PLC on 20, if you have a power on your PLC with DC supply. It would be written on the PLC whether it requires AC power supply or DC power supply. So when it is DC power supply, you have to give 24 volt DC. Another, tell me, what would be the source of 24 volt DC? What would be the 24 volt source of DC? If we have to provide 24 volt DC to power on the PLC, what would be the source? I think you will, some people will say battery. I have seen in many training programs they say that we use battery, rectifier. In college we use RPS, correct? Regulated power supply. But we have to use SMPS, switch mode power supply, SMPS, switch mode power supply. Because switch mode power supply, SMPS, will give you continuous 24 volt DC. If you have RPS, RPS will take 230 volt AC and it will give you a DC power supply. You have seen it will be 0 to 30 volt. Most of the time you will find there. So if you get any fluctuation in its AC power supply, you will get fluctuation in its output also in case of RPS. But in case of SMPS, if you get any fluctuation in its AC power supply, in its DC you won't get fluctuation. And this electronic department, it is in syllabus also, SMPS. So there you will find SMPS we use. So when you have to use any DC power supply, you can have 12 volt or 24 volt or any other, you should prefer SMPS. So in industry also for 24 volt DC power supply, we use SMPS. We don't use battery or we don't use RPS there. Now, input output, you should concentrate on this input output. Input output here does not mean that I'm talking about that relay, contactor or push button or selector switch or other things. I'm talking about input terminals, output terminals. On any PLC, you will have input terminal, output terminal, where you can connect your inputs and outputs, physical inputs, outputs, push button and all. Now this input and output terminals we will have of 3 types. You should note down this thing. This is important. PLC input output terminals we have of 3 types. Relay type, transistor type, triac type, TRIAC, triac. So when we purchase PLC, they will ask you which type you want, relay type PLC, transistor type PLC, triac type. And let me tell you, nowadays we have only 2 types. Initially we had 3 types. Now we have only relay and transistor. So you have to decide whether you want relay type PLC or transistor type PLC. Again, actually, it will take more time to understand why we use relay and transistor. But for your information, you can write down when we have high speed input or output signal. When we have high speed input or output signal, we have to use transistor type PLC. Their relay PLC won't work. because relay cannot read or cannot generate high speed signal. Like high speed signal, you can say high frequency also, you can say high frequency on off. So when we have, you can say encoders, when motor runs in industry or in a college, when your motor is running and you want feedback, rotation feedback, number of rotation, like you want that after 100 rotations motor should stop, so you need feedback from the motor that it has finished 100 rotation. So you need rotation feedback. In rotation feedback you use encoders. We use encoders. Encoder is connected to the moving part, to the shaft or the moving load also. And from there, wire will come to the input of PLC. And that signal will be very high frequent on off. That encoder signal will be high frequent on off. And you know, it is not like in one rotation it will give you one signal, one on signal only. No. When motor is running, if you are using encoder, it will be manufacturer decided that encoder is giving how many pulses it is giving you for one rotation. Like I had used one encoder, it had 36,000 pulses per rotation. So you can see you're not getting only one pulse each rotation. You are getting 36,000 pulses each rotation, and you have to run 100 rotation. So this on-off will be very high frequent. It will be very fast on-off. And this high frequency on-off cannot be read by a relay. It will be read by a transistor. I hope you understand. So when you use encoder, or when you have to use stepper motor, in college generally we use a stepper motor, and in industry for the same application we use servo motor. So to run one stepper motor or servo motor also you need transistor type PLC, because stepper or servo motor won't run by just on and off. It needs number of pulses for each rotation, like 100 pulses. For stepper motor, if you go, it is manufacturer decided, you will have to give 100 pulses from output terminal to the stepper drive. Then only it will run one rotation. For servo motor, I had seen Mitsubishi servo motor, it has 136,000 pulses for one rotation. And this number of pulses will be high for high frequency operation, that we are not going to going into the detail. We don't have time for that. So you have to remember, if you have high speed input or high speed output signal, you have to purchase transistor type PLC, not relay type. For general purpose, you can go for relay type. Okay, let it be. Then you have memory. Obviously, memory, you have two types, program memory and data memory. The memory location where your program will be stored, like when you make program in your computer, laptop, you send that to PLC. That program will be stored on program memory inside the PLC. Data memory. Data means the addresses. You can say the memory location where all addresses are pre-located. It is already there. Which address? The addresses we use in our program, like input address, output address, flag, timer, counter, there are many things. So these addresses are already inside the PLC and it is allocated on data memory. So we have data memory where all addresses are pre-located. Communication port. Obviously, communication port is required to communicate your PLC with other devices. Like if you have to send your program to PLC, you need to connect your PLC to the PLC, and on PLC you will have communication port. Let me show you here. You see, you can have any communication port. It is manufacturer decided. Generally on any branded PLC, you will find RS-232. You can have 9 pin there. You can have 485. You can have this thing. You can have 485. I told you, you can have such type of connector for 485. You have Ethernet connection also on some PLCs you will find there, and RS422, that is round port 8 pins. And here RS232, generally we find RS232 and RS422, but many times 485 also you will find. So you will have at least one communication port on any PLC. If you have more ports, cost will increase. Then we have one extension port also in that block diagram you see. Last one, extension port. This extension port we use to extend the physical capacity of PLC. Once more, extension port of PLC we use to extend the physical capacity of that PLC. What physical capacity? If you have one PLC like I show you here, if we have one PLC, like see this one, this is Mitsubishi PLC, Allen Bradley Siemens. If you have one PLC, on its main unit, you can see you have limited number of inputs and outputs, correct? But it is not like that it can control the limited number only. One micro PLC, these are micro PLCs. One micro PLC can control 256 inputs, outputs, maximum I'm saying, together, input, output together. So if we have this Delta PLC, very small one, it is not like it will control only 6 inputs, 6 outputs only. It will have extension port on this. You can purchase extension input output unit and you can connect to this. And it will be extended, capacity will be extended, you can make program for that. So extension port will also be there. And there is one more thing you need to connect to PLC. ADC, DAC, correct? In academics, we have analog to digital converter, digital to analog converter. For ADC, DAC connection also you have to use that extension port, and ADC DAC will be used because you have not only digital inputs outputs to be controlled, but you have analog input output also, like temperature, pressure, flow, displacement. You can have a control valve and all. For that connection, you can't connect those analog inputs outputs directly to these terminals. These are default digital terminals. Only digital inputs outputs you can connect to the main unit. If you have analog input outputs, then you need to purchase analog input output converters, that is ADC DAC, connect to its extension port. It will be connected in series. Fine, let it be. PLC we have of two types, this micro PLC and modular PLC. Obviously micro PLC will be small PLC, but let me tell you how to recognize. When you see the PLC is a single unit, like all the essential parts of block diagram when assembled in single unit, all essential parts of your block diagram is assembled in single unit, you cannot remove any part. That is micro PLC. Let it be any size, that is micro PLC. And when it is modular PLC, obviously it is big, but you can assemble it yourself also. And obviously when you purchase, it would be separate. Like it will have one base, it will have separate CPU, separate you can say power supply module, you will have separate digital input, separate digital output, analog output, other things. Okay, let it be. Now we should stop this discussion here and we shall go to the important part, PLC programming. This is the most important part. Okay, now let me tell you one thing. We have here participants from different branches. And I have heard we have participants from civil and CS also. Don't be worried. PLC programming can be understood by anyone, and you don't need to be an engineer also. One 10th pass student can also learn PLC programming if he follows proper way. So we are not going to the program directly. If we shall jump to the programming part and I shall tell you, okay, these are the instructions, these are the inputs, outputs, and you make program, it's not like that. You will get confused. So often I follow some steps. And let me follow the step here also. Again, since it will take 5 to 10 minutes to reach to the programming part. Before programming, often I go through this basic electrical diagram. And this is important actually. If I won't go through this, programming you won't understand easily. Obviously, anyone will understand programming. It will take time, but we have to learn in short time. So to learn it very easily, better we start it from basic electrical diagram. Why? Ladder diagram is similar to basic electrical diagram. Don't be worried. It's not complicated wiring. Basic means what? Like you have one switch at your home. You have this socket. You have one lamp or any home appliance. We have to learn how do we connect one switch, lamp to the socket. If you understand that, you will understand PLC programming also, ladder diagram. See how. I shall ask you some question, and you ask this question from yourself. Honestly, you answer it also to yourself, and you see you know about this. It's not like I'm taking any test, but we should know about these things also, because these are very important to work in industry also. Now you see, everyone has seen this socket, correct? Everyone has this. You have to tell me what is this upper terminal for? It is for earth or ground, you can say. But let me tell you, when you go for interview, in one interview it was asked, this is for earth or for ground? It will be either for earth or for ground, but we have difference there. In terms of AC power supply, we call it earth. In terms of DC power supply, we call it ground. See, thing is the same, right? But still, we have to follow the standard. So this upper terminal is for earth or ground. As we shall use here AC power supply, we shall call it earth. And you have seen in your lab also, it would be written ground if it is DC power supply devices. Now you have to answer the important thing. What is this left terminal for? Line or neutral? Either line or neutral. Obviously, it would be either line or neutral. But you tell me universally, standard, what is this left terminal for? Line or neutral? Let me tell you the universal thing. Always this right terminal will be for line connection. Right side is line, left side is neutral. So you have to remember from now, right side is line, left side is neutral. Although we can connect either, but we should not connect either. We should connect the things as per the standard. Right side is always line. Okay, let it be. And when you purchase one socket, it will be written also. It will be written behind that line and neutral. Right side, it will be line. Now I come to this. I hope you have your notebook and pen with you. And you must have that if you want to learn PLC programming. What you do, very fast, you draw the same diagram. You draw the same diagram, please, everyone. You draw the same diagram. I hope you're drawing, huh? Okay. Your task now. Ignore earth. Ignore earth. Line, neutral. Line, neutral. Two terminals. Two terminals on a switch. Obviously, we have two terminals here. And two terminals on the lamp. Any single phase output will have two terminals. So you have to connect these two terminals, and these two terminals in such way so that we can get the lamp on off through the switch. So you have to make a connection, lamp connection, switch connection with the socket. Earth you ignore, you have to connect line neutral, you have to connect these two terminals, and you have to connect these two terminals. Please make it fast. Draw this, please. Now we shall come to the solid. I know only 5% people will practice this also, will follow me. So better we proceed and I come to this. Did you make your diagram like this? Like two terminals will be connected to these two terminals and will be connected to these two terminals. Have you made like this? It is right or wrong? It is wrong. If you have made your diagram like this, if you have connected like this, it is wrong. How you see it? If you connect your line neutral to these two terminals of a switch, inside switch you have one contact. So as the switch is on, this contact will be high and your line neutral will get short. So it will be short circuit and will burn many things if you don't have proper protection. So this is wrong. You please do not connect two terminals, line neutral, both terminals to the switch. You have not to connect both terminals to the switch directly. You see, this is the right connection. You can see line will come to the switch, will go outside and will be connected to the lamp. And from lamp, neutral will be directly connected. Now you see, remember this thing now. Switch, let it be one or many. All your switches will be connected to single paths of your power supply, that to the line path. Once more. You have to connect your switch to single path, that to line path. Do not connect to the neutral path. It won't be safe. I won't go in detail. But you remember this. Further, anytime you can ask me all these things. If you have any doubt, you keep it noted, and further, sometimes you can ask me. So here you see, you have here one switch. It should be connected to the single path. It is connected to line only. It is not connected to neutral. And neutral will be always free. You see, you have not to connect any switch here. Neutral will be directly connected to the output. So switch you connect to the single path, line path. Now, another application. Another application is we have again line neutral. We have two switches and one lamp. Now, as we have two switches, I have one condition. Press other switch. We have two switches, you see. Press other switch and lamp should get on. In that case, both switches will be in parallel connection. So either you press this switch, upper switch, supply will reach to this, or you press this switch, supply will reach to this. So you can see line is connected to both switches and then it will go to the lamp. So switches will be connected in parallel if you have to operate a lamp through many switches. Okay. Now again, another one. This time again we have two switches, one lamp, line neutral. We have to press both switches, then only lamp should get on. In that condition, you have to connect these two in series. So you can see line will go to this switch, will come out, will go to another switch, will come out and will go to lamp. So if you have many switches and you have to press all to get the lamp on, then you have to connect all in series. Done. And you see neutral, you have not to disturb, it is direct. Okay, last one. We have three switches this time, A, B, C. The condition we have, either we press B and C switches, either we press B switch, C switch together, or we press C and A. In both conditions, lamp should get on. So you can see here, as you can see, C is common here. C is here, C is here. B and C, C and A. So C is common here. So C you have to keep in series, other you have to keep in parallel, correct? So either A or B, C will be in series. Either A or B, or means parallel connection, and means series connection. So you see OR connection and connection. So you have to connect these two in parallel, C in series. See, it can be before or after, no problem. Okay, fine. I hope you understand that. Now I come to the programming part. But what I want, for 1 minute, please take rest. 1 minute, take rest. It is for you, not for me. Huh? Take rest. Because we can't concentrate continuously. So distract yourself, and again we shall come to the programming part after 1 minute. Take your time.
If they have any doubts, they can.
I can hear. Okay, welcome back. So now, forget everything. Just start it from scratch. The programming part we shall start from scratch. This one you see. So this is one PLC. As you know, on PLC we have input terminals, we have output terminals. When we have controller, let it be microcontroller or PLC, when we have controller, we have advantage. We do not have complication, that parallel series complication of connection. So we do not have here complication, a wiring complication to connect your inputs outputs. When you have controller, directly your all inputs will be connected to input terminals, all outputs will be connected to output terminals. There is no parallel series connection. And let me tell you, this is not the correct diagram I have shown you here. This is just for idea. This is not the right connection, PLC wiring. I shall tell you that last day, wiring connection. So you just understand that we connect all inputs, outputs directly to PLC. We do not have any parallel series connection here. Now you see, each terminal will have fixed address. We cannot change it. And the address you can have different in different RAM. Like we have considered here, we have to consider here that input we shall use I, output we shall use Q. So input we shall use, input address we shall use when we have to use input in our program. Q address we have to use when we have to use output in our program. If it is I, the input, then I0 is the first input, I1 second, I2, I3, I4. It would be written also on the terminal. On PLC, it would be written. And if it is Q, the output, then Q0, Q1, Q2, Q3, like that we have connection addresses on input-output sides. So we have connected few input sensors here, few outputs we have connected to output terminals. Now, let me give you overview of ladder. How will it look like? So what happens when you open PLC software? You will take new file. As you take new file, it will ask you which language you prefer, and we shall practice it also after break, I think. It will ask you which language you prefer. As I told you, 6 languages are there. So it will give you like 6 languages or 3 or 4. It depends on software. It will give you the option which language you prefer. We select LD, ladder diagram, and as we make OK, ladder will appear like this. You see, this is the ladder, this is the ladder, this is the ladder. The rule, let me tell you. Okay, first you understand this is the ladder, this is the ladder, this is the ladder. So you will have many ladders. We call it rung also, R-U-N-G. You see here, ladder or rung, ladder or rung. You will have network. You see, network 1, network 2, network 3, network 5, 4, 5, like that. Each network will have one ladder. Each network will have one ladder. There are some rules also we need to follow. If you have one ladder and there you want parallel connection, you connect many parallel ladders, you connect, no problem. But the problem is you can't interconnect two networks. You see, I have shown you here in ladder number 2, we have taken here parallel connection, parallel connection, parallel connection. In ladder number 3 and 4, you see, ladder number 3, 4, we have tried to interconnect. It is not possible. Okay, so you understand the rule. So there are many ladders. In one ladder, we can have parallel connection, but two ladders we cannot interconnect. Two ladders won't be interconnected. We shall understand it further also when we will make program. Now you come to the programming part. So here it starts. Obviously, any language will have instructions, like C language. If, else, for loop, other things, printf, scanf, there are many things. Like that, in ladder diagram, because ladder diagram is the language, PLC programming language. In ladder diagram, if you have to make program, there are many instructions. Basic instruction, we are starting from basic. Basic instruction, you have contact and coil. Try to understand. And let me tell you, if you have any query, any doubt, you type it. We will sort it out. If you have any doubt, I shall clarify. You can type it. Now you see, contact and coil. These two instructions are very important, and 90% it will be used in any program you will make. So contact and coil. Now, contact we have of two types. NO, normally open, NC, normally closed. NO, NC, normally open contact, normally closed contact. Ladder diagram will give you facility of symbolic representation. So we use symbols to make program. For NO, you can see this is the symbol we use. NO, normally open. You can see this circuit is open, isn't it? So this is open contact. This is NC, normally closed. It is already connected, isn't it? Connected. Open, NC, normally closed. It is already closed. Let it be. In some user manual or in some old books, you will find it will be written XIC for NO, XIO for NC. It is actually examine if closed, examine if open, examine if closed, examine if open. You don't need to remember this. This is just for your information. To simplify this, remember, NO we shall use when we have to switch on something. Like, see, if you will remember these things, programming will be easy. Once more, NO contact we have to use when we have to switch on any output. NC we have to use when we have to switch off anything. Is it okay? So NO when we have to use when we have to switch on something. Further, I will show you also. And NC when we have to use when we have to switch off. So to switch on NO, to switch off NC, to switch on NO, to switch off NC. So we shall use this for input. And to represent output, we shall use coil. To represent output, we shall use coil and the addresses. So it is clear that to switch on NO, to switch off NC. Now we come to the program. I shall start from the basic example. This is the first example. The first example is press the switch connected to I0 terminal of PLC to get motor connected to Q0 terminal. Let's see once more. I'll simplify it. No need to read this. We have here I0 switch and here Q0 lamp. The question is, press I0 switch, lamp Q0 should get on. This is the question. This is the first program. Press I0 switch, lamp Q0 should get on, because Q0, this lamp is connected to Q0. I call it Q0 lamp. And so once more, I0 switch is on, Q0 lamp is on. Now you see, it is not like that just by connecting your input output to PLC it will start working. You will switch and lamp will be on. No, you need to send one program inside it. You need to send one ladder inside it. So let us make ladder for this. So the example is I0 on, Q0 on. Let me show you how to make program. And you have also to make it. This one, you see, as I told you, to switch on Q0, correct? We have to get this Q0 on. So I have used NO contact. So I0 on, Q0 on, like this we have to make program. This is your ladder, NO contact and coil. This is the program for this application. So when you have to switch on I0, Q0 should get on. This is the final program. We have not to write anything else. This is your program. And finally, we have to send this to PLC, and then we will press I0, Q0 will get on. So this is your first example. Note this down, please. Write down in your notebook. So I0 on, Q0 on. Okay. Now let me explain. How will it work? You can check your program whether it is right or wrong on your notebook only. How? You see this. Try to understand, concentrate please. In this network, left line, you see this left line. This left line you consider is the main supply. You have to consider it. It is virtual. This is software part. It is not real connection. It is software part. In software, this left line is your main supply, and in software you will find it will have some color. It will be indicated. Okay, main supply flow. It will be indicated. So you can see initially means you have not pressed any switch. The machine is powered on, but you have not operated any switch. That is initial condition. So initially, this main supply, you can see it will be up to this contact. It won't go through this initially because it is open. So main supply, you can see it will come and will stop here. So this red color, you can see it has stopped here. It cannot go through this contact because it is open initially. Okay, now this is the initial condition. This machine is powered on. This virtual supply is up to this contact. Now we shall go to the machine, and there we shall press that switch, first switch, I0 switch. As that switch is pressed, I0 address will get high once more. Now you have to go to the machine, and there you have to press that switch connected to I0. As that switch is on, that I0 terminal is high. As I0 terminal is high, inside your software, I0 address will get high itself. Wherever you have I0 will get on. So here we have I0. So as we press I0 switch, physical switch, inside software, this I0 contact will get high. Why this contact? Because we have given I0 address. So now you can see this main supply, red color. Now this is also pressed. Now it will start conducting. When this switch is on, this will start conducting and supply will reach to Q0. It is very simple. Once more. As we press physical switch I0, I0 address is high. As I0 address is high, this contact is high. Now this contact will conduct. And this main supply, this red color you can see, now it can reach to Q0 and Q0. high, this Q0 address is high. As this Q0 address is high, Q0 terminal is high, and connected output, let it be one pneumatic cylinder, hydraulic cylinder, or lamp, motor, whatever. Whatever is connected to Q0 terminal will get high. So it is clear. I0 on, Q0 on. So you can check your logic on your notebook also whether it will work or not. So you have to consider this is the main supply. This left side is the main supply, virtual. Another example you have to make. Another example we are having, okay, you see the solution also, but you should try this yourself also. Now you see another example. We have two switches. We have two switches. Let me tell you, no need to read. If you will read, you won't understand. So we are having two switches, I0, I1, I0, I1, and one motor, suppose, motor Q0. So we have two switches and one motor Q0. As you press either I0 or I1, you can press either, you can press any single switch you can say. So you have two switches, you press any single switch, Q0 should be on. So how we have to make this? We have to make it parallel connection, and I'll show you how will it work. So the condition is here, either you press I0 or I1, Q0 should be on. Our target is this main supply, here it is blue color, this main supply should reach to this coil. This main supply should reach to this coil as per our logic. So our logic is either I0 you press or I1 you press, main supply should reach to Q0. So here you see, this is the initial condition. Initially, main supply, this blue color, I hope you are able to see. This blue color is up to this contact, up to this contact, I0 contact, I1 contact. It won't go through this switch because these two are open now. Now we go to the machine and we press I0, only I0. Now you see, when you press only I0, this path will be active and supply will reach to Q0. So I0 path will be active and main supply will reach to Q0, correct? So Q0 is on. Now you switch off. Now you press I1. Now you see, when you press I1, now lower path. So as you press I1 this time, this path is not active, I0 is not active, but I1 is active, and this I1 contact is high, main supply can reach to Q0, Q0 will be on. So by any mean, by your logic, supply should reach to Q0 coil. So here either you press I0 or you press I1, Q0 coil will be high because this main supply will reach to this. Okay, so this was the example where we have two push button, two switches. Either we press I0 or I1, Q0 should be on. Okay, done. Next example, you try. Again, we have two switches, one lamp. Press both switches this time. Press both switches this time, and Q0 should be on. Press both switches and Q0 should be on. So it should not get on by single switch. It should be on when you press both switches. Q0 should be on. It should not be on by single switch. You see here. Did you make like this? We have to press both switches, so we have taken in series. We have taken in series. This we have done in wiring diagram also. So we have to take these two in series. And let me show you once more. You can check whether it is working or not. See, when we press first switch I0, only I0 we have pressed. So you see, main supply will reach to I1. Main supply will reach here. So when you press only I0, this main supply will reach to I1, but it won't pass through this I1 because I1 you have not pressed. Now when you press second switch also, then you can see main supply reaches to Q0. Q0 is blue. Can you see that? That blue color indicates that Q0 is high. So when you press both switches, then only main supply reaches to Q0 coil. Okay, done. Okay, fast discussion. I hope you understand about this. In colleges or in industry, in interview also, you will be asked some questions related to what we say digital gate programming. Once more, you will be asked question to make program for digital gates. If you have elective subject in academics, it would be asked, or in interview also they ask. Already we have made program for two gates, AND gate, OR gate. You have to tell me which is AND gate, which one is AND gate, parallel connection or series connection. Series connection is AND gate, because here you see the question, this and this, I0 and I1, then only Q0 is on. So this is AND gate, series is AND gate, parallel connection is OR gate, parallel connection is OR gate. How? Either I0 or I1, either this or this. So you see here it is OR. Parallel connection is OR gate. So already we have made program for OR gate, AND gate, correct? So here you see OR gate, AND gate. Now we go for NOT gate. This you should try, this you should try, NOT gate. In NOT gate we have one switch and one motor. In NOT gate we have one switch and one motor. Try to understand. Initially you understand now. Initial condition means the machine is powered on, PLC is powered on, but you have not operated any switch. This is the initial condition. So here you see, initially when you have not pressed I0, Q0 should be on. So output should get on initially only without pressing the switch. And when you press the switch, output should be off. This is not gate, inverse. You have to try this. So I0 is not pressed, Q0 is on. I0 is pressed, Q0 is off. This is just inverse. Try this. Try this once. See this. Can you see this? Actually, it is NC. Can you see this one? This is NC. As it is online mode, I have shown you. That's why I think you are not able to see that cross. So it is NC contact. I have taken here NC contact, and here we have coil, NC and coil. So you can see here, as PLC is powered on, we have not pressed any switch due to NC. As NC is already connected now, you have seen NC contact is already connected. It is already closed. So main supply is here. You see main supply. It will go to this contact, and as NC is there, it will go and will reach to Q0. So without pressing switch, main supply can reach to this Q0. Correct? Now we press the switch. As we press I0, and I0 is NC here, I0 is pressed, NC we have taken here, NC will break the circuit. Remember this. NO is on, it will conduct. NC is on, it will break. Simply remember this. Don't complicate. Please do not complicate with other conditions. Remember this only about NO and NC. NO is on, it will conduct. NC is on, it will break. Remember this one. NO is on, it will conduct. NC is on, NC will break. So here you see, as I1 is pressed, as I1 is on, it will break the path. You can see here. See, it has become white. Actually, when you will use software, this is the indication. When it is blue means it is conducting. When it is Y means it is not conducting, it is broken. So when we press I0, as it is NC, NC has broken the path. So now this main supply has stopped here. You can see main supply has stopped here, blue color. It is not reaching to Q0. It does not reach to Q0. So here you understand. So remember this from now. When you have NO, it is on, it will conduct. When you have NC, it is on, it will break. NO will conduct, NC will break when it is on. Okay, leave it. So this is NOT gate. So this is the initial condition you see. Initially, NO is not conducting, but NC is conducting, correct? Initially, NO is conducting. Here you see I0. Can you see I0? This I0 is initially not conducting, it is NO. But NC, you see, it is conducting because it is NC. Blue color means conducting. This is the initial condition. And you see, when it is on, I have switched on I0 and I1 both. You can see I0 became blue because it was NO, no, it became blue, it is conducting. But I1 became white, means it is broken. So NO will conduct when it is on, NC will break when it is on. Okay, done. Now we come to this exclusive OR. Okay. Once more, you take a break of 1 minute. Take rest actually, don't go anywhere. 1 minute, you revise the things, and then I shall come to the next example. Okay. We have break time, I think. In your schedule, it is break time, so we shall take a break of 10 minutes. Come back soon. Exact after 10 minutes, I shall start the things. Thank you. And you can send your queries also.
All right, the poll has ended. You have the answers. You have the answers on the screen. Like Himanshu, sir, you can discuss the answers.
Yeah, sure. Okay, so first question we have, what is the name of controller where logic is made by wires and electronic components? That is real logic controller, correct? Second is, which important feature is not available in microcontroller required for troubleshooting? That is receiving the program, correct? That is number B. That is B. And third one is, which device we use as power source in case of DC power supply or PLC? That is SMPS. That these three questions we have taken from the discussion only, what we have already discussed. Okay, now we come to the programming part again. As we have very limited time, we have to finish many things. Now, so what we have learned yet, we have learned about programming logic. We have learned that to switch on, we have to use NO contact. You have seen, when we have to switch on, we have to use NO contact. And when we have to switch off, we have to use NC contact. Now you see, now we have to make this XOR, exclusive OR. Exclusive OR is like OR gate only, right? Here also has to get on by pressing either switch, either I0 or I1. Now, one thing let me add. You will make a program for industrial system, for automatic machines. When you will make program, one term you will hear, interlock. So always you have to work on this term, interlock. When you make program, you have to mind that. You have to add that. What is this interlock actually? Interlock means when client will give you some conditions to run the machine. Try to understand. When client gives you some conditions to run the machine, that machine should run for the given condition only, not for any other condition. Condition means the combination of inputs, correct? I take one example of OR gate. OR gate, you remember now. OR gate, parallel connection. There you have seen the condition was I have given, I am the client, you are the programmer. Let us do this. I have given you condition that when we press single switch I0 or I1, Q0 should get off. You made parallel connection. Now you see. Just a minute. So in parallel connection, you see, when you made parallel connection like this, you made this one. So when you made this one, you have taken I0 parallel I1 and Q0. So obviously, when you press I0, only I0, Q0 is on. See this. When you press I0, Q0 is on. And when you press I1, then also Q0 is on. So when you press single switch, Q0 is on. You made this program. And you would be very happy also that you finished. Now, client, as a client, I shall check interlock. As I told, the condition is single button should be pressed. I shall check. When I press both switches, what is the status? Obviously, when we press both switches, it should not get on because I gave you condition, press single switch. So output should get on for single switch only, not for both switches. This is interlock. Now let me check the interlock. And you see, I have pressed both switches. You see here, I have pressed both switches and output is on. It is wrong actually. It is wrong in that case. So this program is not correct if output is getting on by both push buttons. You have not followed interlock. Now, we have that interlock in X. You can see here. In XOR, when you press single switch, Q0 is on. But when you press both switches, Q0 will be off, correct? In XOR, when you press single switch, Q0 is on. And when you press both switches, in that case, Q0 will be off. You try this first. You try this for 2 minutes, and then I shall come to the easiest method to make program. And after that, you will be able to make any program. Try this. The condition is you press I0 or I1, Q0 should be on. But when you press both switches, Q0 should be off. And let me remind you the rule. In one ladder, we can have many parallel connections, but we cannot interconnect two networks. So better what you do, if you have one output, you should take only one output coil in your program. Don't take two output coils. Only one output coil you should take because you have only one output. In NONC, you can take I0, I1 many times, no problem. But coil you have to take only one. Output you have to take only one, but input I0, I1 you can repeat many times. As a NONC in parallel series, you can repeat many times. So make XOR program. If you have made like this, you see here. If you have made like this program, it is wrong actually. In this program, what will happen? As we have NC here, as your system is powered on, this main supply will directly reach, you see, it can directly go through this and will reach here. From here also, you see, you have not pressed any switch, but this main supply will go here. As it is already connected, you see, it will go and will reach to output. So this program is wrong. This is not correct. This is wrong. Correct? Try another one. Try another example. Sorry, try another logic. Okay, now you see. Have you made your program like this? If you have made your program like this, then it is also wrong. This is also wrong. Because here from I0, when you press I0, you see what will happen. When you press I0, it is okay. Q0 is on. But when you press I1, you see, when you press I1, it will go here. As I1 here also you have, no, you see here I1, here I1. NO will conduct, but NC will break it. So your main supply will stop here only. Your main supply is here only. It won't reach to Q0. So this program is not correct. Now, you go for another one. See, some people make program like this also, I have seen. What you will do, as I have given you 4 conditions. So according to your truth table, you will take, okay, this is off, this is, both are off, this should be off. When I1 is on, it should be on. When I0 is on, it should be on. So if you have made like this, the program like this is wrong. Because you have to use only one coil. Here you have used 4 coils. You have only one output, so you should have one coil only. Okay, fine. Better what we do, we don't waste time, and we shall learn the easiest method to make program. Let me tell you, there is no any logic rule, you can say. There is no any rule that you have to make program in this way only. Different person can make program in different way. One program, one example can have many solution. We can have different solution. But what we shall learn, we shall learn the easiest way so that any example we are going to learn, and try to understand it carefully. If you don't understand, tell me, I shall repeat that. But you have to learn this, then only you will be able to make program, any program now after, onwards. You see, I follow few steps to make simple program. What simple program? Simple program means, let it be any input, any number of inputs, any number of outputs. The condition will be simple, just on and off. Here we won't have any complication like we have timer, we have counter, we have pulse, or we have analog, nothing. It's simple. Some inputs are on off, some outputs are on off. We have just on off condition. Let it be any number of input output. You follow these steps. See this. See this one. First, make a truth table for the given condition. First, what we should do? We should make a truth table. Okay, fine. And we should not be overconfident. Confident. I have seen in training programs, they will understand all these things. Obviously, everyone is intelligent here. But what they do, while making program, they make truth table in their mind. And when they make program in their mind, program does not come on notebook. So please don't be overconfident to make truth table on your notebook one. Correct? So follow the steps. First step, make a truth table. Okay, we shall make the truth table. I will show you further. All the steps I shall follow it. First, let us read this. Go to the first output and take a coil for it. Okay. Once we make a truth table, you have already seen we have truth table I0, I1, Q0. So we make a truth table, we go to the first output. So in our XOR program, we have only one output, but we can have many outputs in different examples. So we have not to be worried about all outputs, Q0, Q1, Q2, all. No. We have to go to the first output. And for that output, we should take a coil. Yet we have made program from NO, NC coil, NC coil, like that. For few examples, better you start making program from coil. You start making program from coil. It will help you for few examples. So first make a truth table, go to the first output, take a coil for it. Next, check the true condition of that output. So now you have Q0, you have marked, okay, you have taken Q0. Don't think about another output if you have. You go to the Q0 and check where it is on. In your truth table, it would be 1, 1, 1 somewhere. So when Q0 becomes 1, for that one condition, add the status of all inputs you have used. We have I0, I1. So once more, make a truth table, go to the first output, take a coil for it, check the true condition of that output and add the status of all inputs you have used. Here, don't skip any. We have I0, I1. We have to add the status of I0, I1. When we have to add? When Q0 is 1. Not for 0 of Q0. Okay. Okay, fine. Now, next you see. So now you have to add the status of I0, I1. You have to see when input is 1 for Q01, if your input is 1, I0 or I1, it doesn't matter. If your input is 1, take NO for this. If your input is 0 in your truth table, if your input is 0, you take NC for 0. Once more, for 1 of input, take NO. For 0 of input, take NC. Is it clear? For 1 of input, you have to take NO. For 0 of input, you have to take NC. Okay, okay. Let me show you how we shall make it stepwise. So here I have started. First, you see, I shall notify this. Wait. See this. This is my first step. Truth table. In truth table, I shall get some fumble while saying truth table. No problem. I0, I1, Q0. Is it okay? Now, I0 is off. Both are off. Q0 off. Correct. We have that condition. When only I1 is on, it is on, Q0 is on. When only I0 is on, Q0 is on. Correct, no? And when both inputs are on, Q0 is off. Fine. Now you see. So truth we have. Now, second condition was go to the first output. This is the second output. As we have only one output, it is Q0, no problem. Go to the first output and take a coil for it. I shall make it here also. Take a coil for it. So this is Q0. Fine. Now you see. Make a truth table, go to the first output, take a coil for it. We have done. Now we check the true conditions of that output. Let me check here. You see, output is on, isn't it? Output is on here. When output is on, add this status of all inputs you have used, or add the status of all inputs you have used. So when Q0 is on, what is the status of inputs? You see, 0, 1, isn't it? I hope you understand. When Q0 is on, that time I0 is 0, I1 is 1. So 0, 1, we got the status. So we have to add these status to this coil. Once more, make a truth table, go to the first output, take a coil for it, check the true condition of output and add the status of inputs you have used. For 0 of input, take NC. For 1 of input, take NO. Now you see how to add. You see, for here it is 0. Oh, I0 is 0. So I take it here. So what we have to take for 0? NC. And what is the address of this input? I0. I take this here. I0. Manage place. Now, what is the status of? For 1, we have to take NO. So let us take this. So here it is NO and connect it to Q0. And here it is I1. I1, isn't it? I hope you understand up to this. It is clear. So check the true condition of output. We have checked here and we have added the status of inputs. Again, you go through the same output. Don't think about another one. If you will think about another output, your program will be wrong. Here we have only one output. Let it be. Check it again. Please check it again. When we check it again, okay. Here we find it is on again. You can see here. It is on again. Output is on again here. When it is on again, what is the status of inputs? 1, 0, isn't it? 1, 0. So let me add this now. And you know, this will be added to the same program, correct? So here, to the same program, we have to write. What we have to write for one off input? We have to add NO, correct? No, for one off input, it is NO. What is the address? I1. No, I0 actually here. I0. And for I1, it is 0. For 0, we take? For 0, we take NC, correct? And as these conditions we have for the same output, connect to the same. Is it done? So it is done. So once more, last time, let me revise. Repeat. Make a truth table. Go to the first output, take a coil for it. Check the true condition of output. This is important. Check the true condition of output and add the status of all inputs you have used. All inputs. For input 1, NO. For input 0, NC. Correct? So here you can see I have added NONC. And all true conditions you have to add. All true conditions you have to add. Don't skip any. Remember, do not make program for 0 of output. I have shown you here. Don't make program for 0 of output. It would be already satisfied if you follow only true condition. So you have not to be worried about the off condition of the output. It would be satisfied because you have taken the status of all inputs in your program. And here I have written also, you see, for one off input, this one. For one off input, take NO. For 0 off input, you take NC. Is it clear? Please have a look. Revise. If you don't understand, text it. You don't understood, I shall do this again. Now let me show you how I have made this. See. So I have followed this step, you see. First, I have taken the truth table. Next, first I have taken truth table. Then I have taken here coil. Second step. This is the second step. Third step. Check the status of all. Add the status of. Check the true condition of output and add the status of all inputs. You have done it here. So this is your program, you see. This is the program. So you have to make program like this. I hope you have noted down XOR. And I have just shown you here what happens, how does it get on. Okay, let me show you once. When you press I0, you see, here you can understand it clearly. When you press I0, here we have NC, so it is broken actually. This path is broken. And here you see, I0 is NO, so it is conducting. Correct? No. So here you see, this path is not active, this path is not active, but this path is active. When you press I0. And when you press I1, you see, let me show you. When you press I1, what happens? You see, here you will understand the role of NONC. When you press I1, only I1 you see. This one. So I0 is open here, so this path is not active. But it was NC, so I0 was already up to this. As I1 NO becomes high, this supply will reach to Q0. So now this is active because of upper path. Initially it was active by I0, lower path. And when you press both switches, you see, when you press both switches, this NC is broken. This NC is broken because I0 NC breaks, I1 NC breaks. Both paths are deactivated, not activated. So you see, it is off. It is off actually. Fine, let it be. So you understand how we make program using truth table. For your practice, honestly, you make 2 programs only and you will understand. Then we will go through the software practice also. You will be able to understand it practically. Okay. One example you try. Everyone, please do this. And you have to follow the truth table rule. I shall display that. Here you see. This type, or I think it's better you read this and you can, this one. These all. You can follow the steps. 3 switches I0, I1, I2. 3 switches I0, I1, I2. One output Q0. So we have 3 switches I0, I1, I2. We have one output Q0. In your truth table, you will have I0, I1, I2, and Q0. And conditions. When we press any 2 inputs, we have 3 inputs. When we press any 2 inputs, output should get on. It means we will have 3 combinations actually. Let me show you combinations first. See this. Here. We will have 3 combinations. You can see it is on here, on here, on here. No need to make a big truth table. You just take for on conditions. So when I0 is on, I1 is on. So when you have I0 and I1, both 2 switches are on, third is off, Q0 on. Second condition. When you have I1 and I2, 2 switches on, Q0 on. Third condition. When you have I0 and not this one. I told all 3 conditions once more. When you have I0, I1, I1, I2, and here actually, here, I0 and I2. So you have 3 combinations. 3 combinations, I0, I1, I1, I2, I0, I2. For these 3 conditions, you take 1 of Q0, and for other it would be 0. So make a truth table like this one. You copy this place. Make this place, everyone. Note it fast. This is the truth table. Note down. Did it? Now, next. So this is your first condition right now. Make a truth table. This is your truth table. Next would be go to the first output, correct? No. Second one, you see, second step. Go to the first output. Here we have only one output. Go to the first output and take a coil for it. Correct? This is your second one. Next. So make this one, make this ladder, make this ladder. Okay. Next. Follow me, follow me stepwise. Third is we have to, in this only I am telling you, we have to check the true condition of output. Correct? Output is on here, output is true here. So check this. After that, add the status of all inputs you have used. How many inputs do we have? 3. Now let us check the status of input. What is the status of input? 1, 1, 0. Correct. So what it should be? 1 means NO, 1 means NO, 0 means NC. Did you understand? Did you understand this? So here you have I0, I1, sorry, and I2. Okay. So this is for your first true condition of output. Okay. After adding this, again you have to go to the true condition of output. Can you see this? I have again gone to Q01. And when it is on again, what is the status of input? Check this please, everyone. What is the status of inputs? 0, 1, 1, isn't it? So tell me, what should be the ladder? 0 means this one. 0 means what we have to take? NC, correct? then 1. What we have to take? NO, and again 1. So it will be NO, and where it will go? With the same, correct? No. Now, again the same address, I0, I1, I2. It is not over. Again you go to check whether it is on again. Yes, Q0 is on again. When it is on again, what is the status of inputs? 1, 0, 1. Add this. So what it should be? 1 means NO, 0 means NC, 1 means NO. Again you have to connect here. Again the same address, I0, I1, I2. This is the program. I hope you understand. Note down, please. So this is the program, you see. This is the program. So 2 NO, 1 NC, 2 NO, 1 NC everywhere. I hope it is clear. Now I shall go for next example. This is the initial status. Initial status, you see, let me show this also. In initial status, this is your main supply, and supply, you see, this main supply is up to this in upper ladder. In lower, you see, in middle, you see, this supply can pass through NC and can reach here up to this. And in third, you see, it is up to this and it is already connected because of NC. So when you will press this one, then supply will reach here. Okay, let it be. You understand that. So it is clear that we have to follow few steps, and programming is very easy. But let me tell you one thing, what I have found in classroom training. Up to this, people do very well. And after this, they start thinking. Thinking means they start applying their intelligence, mind, and program gets down. So I request you people, do not use it would be rude, kind of rude you will hear, it will sound. So please do not apply your mind while making simple examples. Just follow the steps. If you will follow your mind, if you will use your mind, your program will be wrong. By sure. Let me show you. You can check this also. Let me give you one example, and you will find that if you think more, your program will be wrong. And the example is, you have to make this. You all have to try this. We have two I0, I1. I0, I1. And three outputs this time. We have three outputs, not single output. And name I have given, it would be a blue lamp, green lamp, and red lamp. Condition is, when I0 is on, only I0, you see, only I0, then only green should be on, not red and not blue. When only I1 is on, you see, blue and green both should get on, red should not. And when you press both switches, I0 and I1, in that condition, only red should. When you press I0, only green should be on. When you press I1, only I1, blue and green both will be on. When you press both switches, only red will be on. And let me remind you the rule. We have three outputs, so we should have three coils only in our program. Do not take many coils. Don't repeat the coil. Input you can repeat. I0, I1 you can repeat in advance. But I think it's better you follow all those steps. If you will follow the steps, you will get solution. Okay, try this first. 2 minutes you try and follow the steps. I shall put the screen on steps, and you follow the steps, you will get solution. This one. These steps you follow, please, and you will get the things. First, you should make a truth table. First, make a truth table, everyone. Make a truth table. After making truth table, you have to go to the first output. You have 3 outputs, blue, green, red. So don't think about all outputs. You just simply go to one output. You can go to any output, but it is better you go to the first output. Take a coil first. Don't start from NO and C. If you start from NO and C, it would be wrong. Start from coil. You take a coil for blue. Now you have to go to blue in truth table and check where it is on. You have to check where blue becomes 1. When it is 1, add the status of I0, I1, and wins. And when blue will be done, then only you go for another output and take coil. Separately, you take program for green. Separately, you make program for red. So do not interconnect, do not relate 2 outputs. Separate program for blue you make, separate program for green you make, separate program for red you make, it will be correct. So one by one, you make it, please. Everyone. 1 more minute. You make this and then I shall show you the solution. Okay. Okay. Tell me, did you make program like this? Have you made program like this? Like you have taken blue and green both in one ladder? Have you made like this? Blue, green, both in the same network? In network only one? You have not to do like this. If you will do like this, the problem will be when you have to press I0, only green should be on, but in this case, both will get on. So your program will be on. So this is incorrect. This is not right. Now you check this one. Have you made program like this? Have you made program like this? See this? If you have made program like this, then also it is wrong because you have taken blue twice, you see. See this? Blue, blue. Your program is wrong. Do not repeat coil address. Do not repeat coil address or else it would be wrong. So I told you, no, we have 3 outputs and how many coils you have taken? 1, 2, 3, 4. We should have only 3 coils, output coils, correct? So it is wrong. It is also not correct. Now, better we follow the steps and you see the steps. First, we have to make the truth table, correct? We have made the truth table here. After making truth table here, everyone will concentrate and will see where you have made mistake. And I'm sure many people have made mistake. Now, after making truth table, we have to go to the first output. Don't think about these 2 or else your program will be wrong. Only this one you think. We don't have these things. Don't think. So only blue. Take a coil for it. I have taken. So check the make a truth table. Go to the first output. Take a coil for it. I have taken. Now check the true condition of output. First, off. Don't make. On. You have to make. Correct. When output is on, you have to make program. When output is off, you have not to make program. So when it is on, what is the status of inputs? Here, 0. 1, correct? No, this one. When output is on, it is 0, 1. For 0, what we take? NC. For 1, what we take? NO. Correct? It is done. So blue is finished. Because when blue is 0, we have not to make. So blue you have finished. Now I shall go to another output. I shall go to another output. And will take coil for green. I take coil for green. Q1 actually, no problem. Now check the true condition of green. Green is on here, correct? No, green is on here. When green is on, what is the status of inputs? Tell me. 1, 0. Add this. For 1, what we take? NO. For 0, what we take? NC. And it is connected. It is okay? Obviously, I0, I1. I0, I1. Done. But it is not over. Don't go to another output. Check it again. When you check it again, you see, again it is on. When green is on again, what is the status of inputs? 0, 1. Add this, add this, add this. For 0, what shall I take? NC. For 1, what shall I take? NO. To the same output, correct? To the same output. Again, it is I0, I1. Now again you check, it is off. When green is 0, no need to make program. So we have made program for on, green on. It was on twice. We have added, green is finished. Now you switch to next output, that is red. That is red. So again, go to the red, take a coil for red, check the true condition. Off, do not make, off, do not make, on, you have to make. Now when red is on, what is the status of inputs? 1, 1. So you have to add it. For 1 you take NO, for 1 you take NO and add this. It is done. I0, I1, I0, I1. It is done, correct? So finally it is finished. So if you go through step if you go through a step or you follow a step, you will get the solution. And you see, finally you will get your program like this. So this is your final program. Actually, this is one single program only. We have not to take 3 programs or 3 files for each output. It is one program only, but we made stepwise. Finally, in network 1, this is network 1, we have taken this, network 2 and network 3. So 3 networks we have used, and this is our program. I hope you understand. Now we shall stop making program and we shall see software. It is important. And rest example we shall make tomorrow. So now let us work on software. I hope you have installed software, Codesis software. We have Codesis software here. We have to practice on Codesis. If you have installed, then you should search COD or CODESYS, Codesis. You search that in your laptop. Do you have this V2.3 and this symbol, this logo? If you have this, you click it. It will be open. You can add this to your taskbar. So you have to search Codesis and open it. You see. This is my previous program. It is showing you. You won't get this as you have installed it now only, today only. So it won't show you. This is my previous program. This is the importance of this software. Only this software will have this design option. And let me show you. Although we are not going up to that extent to learn all these things, but basic I will tell you. You can see this is very good for our presentation and all. If you have to make some presentation for a student, or student have to make presentation for their project, they can write the logic in ladder, and in the same file they have option of design. They can design this. You see, it will be running also. Okay, let it be. So what you have to do? Have you opened it, everyone? After opening the software, you can text. If you have not installed the software, you text how many people have not installed. Now, We have to take one new file. Can you see everyone? File to this corner, take new. You will get this. Did you get this one? None. We have to keep it none only because we have to work in simulation. When we work with PLC hardware, then we have to mention here the PLC hardware name. So for now, you have to keep it none only. Make it okay. And now you see these are the languages: IL, LD, FBD, SFC. There are many languages. We have to select LD. Everyone, please select LD. Can you see this one, LD here? Or I shall notify. This one, LD. This one. So select this and make it okay. Maximize. So you can see you have got here one ladder, one network. We have one network here. We have one network here. If you want more networks, obviously we want more networks. In next example, we shall need. We have option right click, network after or network before. It is shortcut is Control T. Control T. Let me show you. Control T. New ladder will come. If you want to delete, simply press delete. It will be deleted. So we have to take a new file. We got this ladder. Everyone. We shall make XOR program altogether. We shall make XOR program altogether. So follow me and make this. Are you able to do this parallelly, or first you will see this? I think it's better if you are able to follow me parallelly and you are able to make program, you make it, or else you just see how we make one program in this software and how we execute. If I have to take NONC coil here, I will have to first click this ladder, and you see it is selected. I have clicked this ladder. You have been given here that NONC coil you see here. NO, parallel, NC coil, everything has been given here. So I click this ladder and I shall take here one NO. See, it came, correct? Again, I click this ladder and again I take this, it will come here. Again, click the ladder. Every time you click the ladder to take element, take a coil. Now again you click the ladder. You want parallel connection, correct? No. For parallel connection, if you want parallel below this contact only, see this, I hope the cursor is visible. If you want parallel below this, click this and take parallel. It will come below this. But we want below both contacts. So I click the ladder and will take this. Is it clear? It will come. We want one more contact here. We have two options. First is you click the ladder, take one arrow, click and drag. Click and drag. As it becomes green, can you see this green here blinking? As it becomes green, leave it. It will come inside. Another option, better, click this one, parallel contact. Click this and take one more arrow. It will come inside. Done. Now we have to make NC also. I click this and I shall make it NC. I shall click this and I shall make it NC. You can remove NC also, no problem. Fine. So in this way we make program. First, everyone finish up to this. Everyone finish up to this. I hope you have made up this. Now we need to give addresses. In our program, we have used I0, I1, and Q0. But it is not like that everywhere it will accept I0, I1, Q0, or blue, green, red. Different brand will have different address. Different brand of software, PLC software, will have different address. We cannot change that. As per them, we have to write the addresses. In Codesys software, you can note down first, input address is percentage IX 0.0. Another input, it would be IX percentage IX 0.1, 0.2, like that. You can take maybe. For output, you have percentage QX 0.0. You have to take like that. For another output, obviously percentage QX 0.1, 0.2, like that. You have to take address. You have not to write blue, green, red, or kind of thing. You have to follow the addresses. I shall do this with you. So I hope you have noted down input address percentage IX 0.0, 0.1, output address percentage QX 0.0, and so on. So I write down the address here. You see, I click this and I shall type here percentage IX 0.0. This is also 0.0. You can copy it, click this, Control C, Control V. So we have to, we can actually copy the address also. You can click the address, you can do Control C or right click, copy it. Here, Control V, but it should be I1, so make it I1. This is also I1, Control V, I1, done. And what is the address of output? Percentage QX 0.0. Write it fast, please. Write down, write down. You go to your program and write the addresses. Go to your program, write the addresses. Is it done? Okay, fine. Now you see. If you have finished, it's okay. If you have not, then try to make it fast and see how do we execute it. How do we simulate? You can say, how do we simulate it? We have to check whether it is working or not in simulation mode without PLC. For simulation, I think it's better you write down the steps, because further after training, if you have to work on the software, you have to see the steps. You won't remember all the things. It is my guarantee. Write the steps to execute. Online, write down online log in. Online log in. You can see on the screen also. It is online log in. First step, correct? Again, online run. Online run. So we have login run. We have to do login run to execute this program. And login run both we have in online. Look at the screen, everyone. Look at the screen. This is the shortcut. Login, log out is run. So I do this. Let me show you. First, I shall execute, and further you can execute your program. First, you see everyone. Look at this screen. Login So you see it is logged in. Now we go to run mode, run. Double click I0. If you have to operate any input now, you have to double click that input. I double click this. I have clicked it. So you can see the input is selected. Now it is selected only. It is not on actually. So we have selected I0 by double click. Now to get it on or off for both, we have the same function. Control F7. Control function key 7 in your laptop. Control F7. It is the shortcut. First, let me show you the shortcut, and then in option also, in file option also, I will show you. So I press Control F7. And you see, I pressed Control F7, it is not working. And the reason is I have function key. I will have to click Control plus function, then function key. In some laptops, it would be like that. So if it is not working by Control F7, then press Control plus Fn. Fn key you will have beside Control. So Control function, then F7. You see, now it is on, isn't it? So you see, this blue color reaches to Q0. This blue color is the main supply. It reaches to Q0. Is it okay? So what is the condition? We have pressed I0. We have pressed I0. Now we need to switch off I0. I0 is on. Now we want to switch off I0. And to switch off, again, double click I0, Control F7. You see. Now this is the initial condition. This 0, 0 means both inputs are off. Because you see both NC, we have blue here. Both NC blue means we have not pressed it. Now we have to operate by I1. So I double click this, double click I1, Control F7. You see, now it is on by I1 NO. Correct? No, it is on by I1. It is on. Again, you switch off. This time, let us check for both switches. When we press both switches, what happens? Double click, correct? We have selected the switches and we press F7. So what should be the result of Q0? Q0 should be off only. It should not get on. So Control F7, you see. Q0 is off. Why? Because this NC is white, means it is breaking. I1 NC is breaking the path. This NC is white, means I0 NC also breaks the path, correct? So both NC contacts break the path. So I1 breaks here, I0 breaks here. So supply stops here, supply stops here, Q0 is off. Again, double click both, Control function F7. Once more, double click the input, Control function F7. Or you can go to online. You see, this is also one option. If it is not getting on off through your keyboard, then you can go to online, write values. Can you see Control F7, the shortcut here? So from here also you can operate it. Okay, fine. Everyone do that. So what you have to do, you go to log in, online login. First you do online login. Then again you go to online and make a run. So you have to do login run. Have you done that? Login run. As per your truth table, you have to check. Now press I0, means double click I0, Control F7. Double click I0, Control F7. Double click I0, Control F7. Is it done? So Q0 will be on. Now again double click I0, Control F7. Again double click I0, Control F7. So I0 is off, Q0 is off. Now check from I1. Everyone check from I1. Double click I1, Control F7, Q0 is on. Again double click I1. Again double click I1, Control F7. Q0 is off. Done. If you want to check for both, then you double click I0, double click I1, double click both, and do Control F7. Control F7. So you can see Q0 is off. Okay, fine. Everyone go to online, do log out. Online, log out. Online, log out. For any modification, you need to go to offline. Offline is log out. In log out, you can modify. Better, you take a new file. Take a new file. Better, first you save your program. Huh? Save your program. Take a new file. Save your program and then take a new file. Select LD. Okay. Take a new file and make another program. You all have to make now blue, green, red program, and please make it fast because lastly you have again a poll question session. You have to answer 3 questions. So make this fast. You have that program, blue, green, red. Had you written that program, blue, green, red program, or shall I show you? Okay, better I also make with you. But we both cannot make parallelly. Once check this, have you made program like this? Q0, Q1, Q2. It is important. You have to take here Q0, Q1, Q2, percentage QX 0.0, percentage QX 0.1, percentage QX 0.2. Have you taken this? If you have made this program, then you go for login, run, and as per your truth table, you check whether it. To get the input on, you have to double click the input, control F7, and to get input off also double click control F7. Do that. Okay, see this. after making the program, after making ladder, you have to go to online log in. You have to do online log in. Again, you have to go to online and run. Correct? Online login, online run. After that, you have to check as per your truth table. First, we press I0. So double click I0. Double click I0. Then control F7. Control for 7. You see. So Q1 is on. That is green. Correct? No, only green is on. Now switch off I0. Double click again. Control F7. It is switched off. Now I1. Double click. Control F7. You see, when you press I1, this time we have pressed I1, I0 we have not pressed, I1 only. When we press I1, as per our program, as per the table, blue and green both should get on, and you can see blue and green both are on. First you switch off I1, double click, Control F7. Now we shall press both the switches, double click, Control F7. And you see, this time last output Q2 is on, red. This is red. Red is on. Is it clear? Is it clear now? I hope it is done. Now let me show you the visualization. The very interesting part of this software visualization. How do we design the things? Obviously, we shall go for basic design. If I go for XOR, let me show you in XOR so that I can finish the things early, fast. I shall open XOR. You just see this only and try to note down the steps also parallel. I shall open XOR. See this. This is the XOR program. When you have to make visualization, I think it's better what I shall do, the steps in detail I shall write down and will email you. For now you see this. For now you see how we make this. For visualization, visualization has no relation with your logic. What is the logic? How machine is working? It has no relation. It is design part. Design has no relation with logic. In design, you have to just take addresses from your program and you have to design it. Like in this program, we have to take one switch I0, another switch I1, and one output Q0. Correct? So three things we have to visualize here. For visualization, we must go in offline mode, means online logout. Online logout is required. So in logout, we go to, can you see this here? This one. Can you see this one? I'll tell you what is that. Third element, first, second, third, fourth. Can you see this part? 1, 2, 3, third. Third is visualization. It is visualization. As I click this, see here it will come. As I click this, here it has come, visualization, correct? Right click, add object, right click, add object. You don't need to write down, I shall send you the steps after training, after this session. Add object, give any name you can give, what it accepts, make it okay. We got this screen for design. If you have to go back to ladder, then the shortcut is Control F6, or you can go to the first element. Visualization is third one, ladder is first one. So I click ladder, first one, and double click. It will come. Go to third one, visualization, double click, it will come. Correct? Control F6 you can use. Now, first I shall tell you how do we design a switch. See, we can use any element here to design a switch. It depends on us how we design. So I take this one. I have taken rectangle. I double click this and I get the option. We got this option. Three things we have to do. First, color. Second, change color. Third is input address. First, we have to give the color. Second is when we have to change the color. And third is input address. For input, we have to follow 3 steps. So I go for first one, input. Color first. Colors. Can you see here colors? In color, this is initial color. This is after on color. So initially it is already white. No, let it be white only. So don't disturb initial color. This is alarm color. Then go to in variable, we have here change color, and we shall give here input address percentage IX 0.0 I have given here. So I have given here percentage IX 0.0 I have written there. Then I go to input. And input we have toggle variable, as we have been working on toggle switch, push button we will work tomorrow on. So here toggle variable and input address percentage IX 0.0 done. So what we have done, color, alarm color, variable, change color, input address, input, toggle variable, input address. Okay. Now we want one more switch, so better we copy and paste. Control C, Control V. We got another, we just need to change the address 0.1. In variable also 0.1. Done. Okay. Now you go for this one. Any design you can take. For output also you can take rectangle, no problem. You take any design. Design depends on you, I told you. So it doesn't matter how I design. So I have to take here one circle or anything. I double click this. We have to follow 2 steps only. What 3 steps we have followed for switch? Only 2 steps for input. The same. First color, alarm color, take some color. Then variable, change color. When we have to change the color of output, when output is on. So what is the address of output? Percentage QX 0.0. So when percentage QX 0.0 will be high, it will change the color what you have taken in alarm color, from white to alarm color. Input is not required. For output, third step is not required, that is input. Okay, it is done. So we have taken 2 switches, 1 output. Let me show you. You don't need to do double click Control F7 all the time. We have program behind it, you see. Without program, it won't work. You see, you have one program. Without program, this visualization won't function. Now, I do the same. Login, run. Or from online, you can do login, run. First switch. When we press one switch, I0, you see Q0 is on. Correct? No, Q0 is on. As per your logic only, it will work. Switch off. Switch on another. Click. It is on. Now, if I press both, you see, both, it is off. So you see, both switches are on, output is off. Fine. I hope you understand the steps I shall tell you, how we have to go to the visualization file and how we have to design the switch and output. And obviously, we shall go for poll question, but first let me give you homework. How you will submit your homework? You have to make program. One program I shall give. You have to make program. Screenshot you have to email to the given email ID, what will be provided by the organizers. You have to send the screenshot of ladder and visualization both. Screenshot of ladder and visualization both, what I'm giving you now. So now you go for homework. This one. We are having 4 inputs, 4 outputs. Write down please, everyone. Or better you can take screenshot of this also. Or I shall ask them if we can email you this one.
Yes, sir, we can send an email.
We can send email?
Yes, yes.
Okay. But let me explain you what is this example. So no need to write down. You will get the email, everyone. So see what is the example actually. We are having 4 inputs, I0, I1, I2, I3. And we are having 4 outputs, Q0, Q1, Q2, Q3. Name is pump 1, pump 2, red and green. Pump 1, pump 2, red and green. When only I0 is on, pump 1 and red will be on, correct? When only I0 is on, pump 1 and red will be on. When only I1 is on, pump 2 and red will be on. When only I2 is on, pump 1, pump 2 and green, these 3 will get on. And when I2 is on anytime, when I3 is on, anytime when I3 is pressed, all outputs will be 0, all outputs will be off. So you don't worry about this, you just follow the steps and you will get solution. So you have to make ladder for this and you have to make visualization also, both screenshot you have to send. We shall go through the poll questions, please. So here is the poll question, answer it please.
The poll questions are on the screen.
I think we have to answer.
Yes,
question.
yes. For the second question,
You
for
can
the
leave
second
that.
yeah. Please ignore the second question, or you can send in the answer in your chat box. For the second question, please answer it using the chat box. Two more minutes to go. All right, the poll has stopped. All right, the answers are on the screen, so you can go through them. So the answers are on the screen.
Contactor is not the type of input-output terminals. Which software we use today? Codesys. And normally open, normally closed for a second. Okay, actually these questions are very easy for you. From tomorrow we shall pick it up. I hope you covered today. And if you have not understood, no problem. Further we shall clarify. And if you have any query, you can collect. You can send your query to Venu sir, and he will send me. And I shall try to clarify offline also. I hope to see you people again tomorrow. Thank you very much.
Sir, like Himanshu sir, there are one or two doubts that have been asked. If we can just address it now.
Yes.
Yeah, there is one question from Mr. Sandesh Naik. Is it possible to edit the ladder diagram while PLC is online in the industries?
Actually.
Is it possible to edit the ladder diagram while PLC is online?
That part, if let me show you on screen also. That part I skipped. With PLC, I shall show you. When we were comparing that PLC and microcontroller, here you see. You can see on screen it is online edit here. Online edit. When PLC is working, it is online, like machine is running. And while run mode also, if you want to make modification, it is possible. It is possible in PLC. In PLC software, you will get option. The name can be different for different software, like online edit or any other name. It doesn't matter. I shall show you that when we shall work on PLC last day in Mitsubishi. I will show you. It is possible. And when PLC is working, machine is running, and while running mode, you want to receive its existing program, that is also possible. But while sending program, PLC goes in stop mode. If you don't want to stop, you use online edit. Yeah. Next.
Yeah, that is all for now, sir.
Mhm.
So I think we will stop the session. Yeah. If you have any more doubts, please email it to us, and we will take it up in to tomorrow's session. All right.
Thank you.
We will like, see you again tomorrow morning. I mean, I request you all to log in at least 5 to 10, at least 5 minutes early so that we can start the session on time. Yeah.